Good day, everyone. My name is Michael Stahle, and I'm honored to present at this year's ISC Squared 2024 SECON Conference. Today, I'll be discussing a transformative topic that bridges the worlds of artificial intelligence, cybersecurity, and software development: the utilization of agentic large language models to automate cybersecurity code reviews. With over 2 decades of experience in cybersecurity and program management, I've had the privilege of overseeing major U.S. Air Force projects and developing innovative solutions in cloud architecture and security. My recent work focuses on integrating advanced AI tools into DevSecOps pipelines, tackling some of the most pressing challenges in secure software development. In this presentation, I'll outline how agentic LLMs, supported by frameworks like Retrieval Augmented Generation, RAG, can reshape code reviews by reducing human workload, enhancing security posture, and aligning with the rapid pace of modern development cycles. We'll explore methodologies, key technologies, and the profound impact this approach can have on our cybersecurity practices. Thank you for joining me, and let's dive into the exciting possibilities AI brings to cybersecurity. Let's start by addressing the current state of cybersecurity code reviews. As many of you know, traditional manual code review processes are not only labor-intensive, but often struggle to keep up with the pace and complexity of modern software development. Consider this. For every cybersecurity professional, there are dozens, if not hundreds, of active developers. This creates a critical gap, making it nearly impossible to thoroughly review all the code produced in a timely manner. Add to the constantly evolving threat landscape, where new vulnerabilities emerge almost daily, and it becomes clear that traditional approaches are insufficient. This is where artificial intelligence, and particularly agentic large language models, come into play. These advanced tools can automate many aspects of code review, from identifying vulnerabilities to generating actionable insights in real time. They enable us to shift from reactive to proactive security posture, aligning with ever-changing security standards without the need for constant manual intervention. AI doesn't just make this process faster, it makes it smarter. By automating repetitive tasks and leveraging tools like Retrieval Augmented Generation, we can not only scale our efforts but also ensure a more secure software development lifecycle. Now that we've set the stage, let's dive deeper into what agentic LLMs are and how they work in cybersecurity. Now that we've set the context for the challenges and opportunities in cybersecurity, let's explore the role of agentic LLMs. These advanced AI models are not just static tools. They are dynamic agents capable of autonomously or semi-autonomously performing complex tasks. At their core, agentic LLMs use advanced neural language processing to understand, analyze, and act upon codebases. They've trained to identify vulnerabilities, generate comprehensive documentation, and even suggest corrective measures, all while operating in real time within the development pipeline. One of the defining characteristics of these LLMs is their ability to adapt dynamically to different tasks. By leveraging frameworks like Retrieval Augmented Generation, they can incorporate external data sources, such as updated security guidelines, into their analysis. This ensures they remain relevant and effective in a constantly evolving security landscape. Additionally, tools like LangGraph and AutoGen also allow these models to be integrated seamlessly into workflows, making them invaluable in automating cybersecurity reviews. Their decision-making capabilities and task prioritization help alleviate the manual burden while enhancing the thoroughness and accuracy of reviews. As software development grows in scale and complexity, traditional code reviews have become a bottleneck. They are not only resource-heavy, but also prone to human error, especially when developers are tasked with reviewing hundreds or thousands of lines of code. Moreover, with the constant evolution of security guidelines, like the Department of Defense Security Technical Implementation Guides, manual reviews struggle to keep up. This lag can lead to vulnerabilities being overlooked and systems becoming non-compliant. Automation offers a game-changing solution to these changes. With agentic LLMs, we can integrate real-time vulnerability detection into the development lifecycle, drastically reducing the time spent on reviews. Automation also ensures accuracy by leveraging advanced AI to identify issues that may be missed by human reviewers. These systems are designed to adapt to evolving security standards, keeping our codebases secure and compliant without requiring manual intervention every time new guidelines are released. Perhaps most importantly, automation scales effortlessly. Whether it's a small codebase or a multi-million line enterprise application, AI-driven tools handle the workload efficiently, freeing up cybersecurity professionals to focus on more strategic tasks. The methodology begins with creating a robust foundation for cybersecurity reviews using graph databases. First, we identify the relevant STIGs. These are the DoD guidelines for secure coding. These STIGs are stored in a vector database, which allows us to embed them into the system for real-time analysis. Next, we clone the target repository and initiate the graph database. This enables us to model code objects and their relationships dynamically. Parsing the code repository into individual components allows for more granular analysis, ensuring that nothing is overlooked. The final step in this phase is embedding STIGs and code entities using LLMs, which creates a semantic link between code and security guidelines. The second phase focuses on applying agentic workflows to identifying vulnerabilities. Using retrieval augmented generation, RAG, tools like GraphRag, we enable the system to conduct contextual queries and analyze the code intelligently. We define workflows for the agent to operate autonomously, integrating LangGraph to handle queries and responses efficiently. Standardizing outputs with tools like BAML ensures that the reports generated are actionable and easy to interpret. The result is a comprehensive analysis that highlights vulnerabilities and provides remediation suggestions. Graph databases like Neo4j are at the core of our methodology. They excel at modeling relationships within complex datasets, such as the connections between code objects and security guidelines. This enables us to perform highly efficient and detailed analysis, even for large codebases. RAG is a powerful AI framework that bridges the gap between static data and real-time generative capabilities. By integrating external sources, such as updated STIGs, it ensures our vulnerability analysis is always aligned with the latest security standards. LangGraph facilitates seamless integration between LLMs and graph databases, enabling efficient workflows for querying and analyzing vulnerabilities. AutoGen, on the other hand, automates many of the repetitive and time-intensive tasks associated with cybersecurity reviews, such as parsing and scanning code repositories. Together, they streamline the integration of AI into DevSecOps pipelines. Finally, BAML ensures that the outputs generated by our system are standardized, actionable, and easy to interpret. This is critical for maintaining clarity and consistency when communicating identified vulnerabilities and remediation steps to development teams. Integrating agentic LLMs into the DevSecOps pipeline is where the real magic happens. By embedding these workflows directly into the CI/CD process, we ensure that security is no longer a bottleneck. It becomes an integral, automated part of the development lifecycle. This approach aligns perfectly with the principles of modern DevSecOps, which emphasize continuous integration, deployment, and feedback. First, LLMs are embedded into the CI/CD process to provide real-time analysis of codebases. These models continuously adapt to the evolving security standards, ensuring that vulnerabilities are identified and addressed proactively. Next, tools like RAG enable automated vulnerability detection. This ensures that potential issues are flagged without slowing down the development process. Frameworks like LangGraph and AutoGen scale functionally, making it feasible to handle even the most complex and large-scale codebase efficiently. Finally, the system generates a feedback loop. Actionable insights are provided directly to developers, while standardized reports are delivered to security and compliance teams, ensuring that all stakeholders remain informed and aligned. Imagine a pipeline where every commit triggers an automated review by agentic LLM. The system analyzes the code, checks against the latest STIGs, identifies vulnerabilities, and provides developers with real-time feedback. Meanwhile, compliance teams receive reports that ensure the organization meets all security requirements. By now, it's clear integrating agentic LLMs into the cybersecurity review process isn't just a technological advancement, it's a necessity. Let's take a moment to explore the advantages this approach brings to organizations striving to meet the demands of modern DevSecOps. First, automated compliance ensures that our systems continuously align with updated guidelines like STIGs. This eliminates the need for manual intervention whenever a new security standards are released. Next, automation dramatically improves accuracy. Human error, which is often a factor in missed vulnerabilities, is minimized. Every piece of code is reviewed consistently and comprehensively. Efficiency is another major advantage. By automating repetitive tasks, we free up cybersecurity teams to focus on higher value activities. The system's ability to scale means it can handle projects of any size without sacrificing speed or quality. Finally, this approach fosters a proactive security posture. Vulnerabilities are identified and addressed early in the development cycle, reducing the risk of late-stage discoveries that can lead to costly delays or breaches. While advantages of automated cybersecurity reviews are significant, it's important to consider the challenges and limitations that come with implementing this approach. Understanding these hurdles helps us plan more effectively and make informed decisions about adaptation. One major challenge is the dependency on training data. The accuracy and reliability of agentic LLMs are directly tied to the quality of its training data. If the data is incomplete or biased, the system might generate false positives or overlook critical vulnerabilities. Integration complexity is another factor. Incorporating these advanced tools into existing DevSecOps pipelines, especially in organizations with legacy systems, can require significant effort. This challenge is compounded by the need for ongoing maintenance and updates to keep the AI aligned with evolving security standards. Cost is also a consideration. While automation reduces long-term operational costs, the initial setup and ongoing management can be resource-intensive, particularly for small organizations. Finally, ethical and security concerns are critical. We must ensure AI outputs are explainable and compliant with standards, while also safeguarding against potential misuse of these technologies for malicious purposes. To demonstrate the practical application of this approach, let's look at a real-world use case transitioning USAF systems like MSDIS and LD2RMS, systems I'm personally responsible for, into Cloud One Azure. This large-scale migration required ensuring that systems met stringent DoD cybersecurity standards while operating within a fast-paced DevSecOps pipeline. During the migration, agentic LLMs were integrated to perform automated code reviews. These models continuously monitored the codebase for compliance with DoD security technical implementation guides, identifying vulnerabilities in real time. The results were impressive. By automating the review process, we reduced the time spent on code analysis by 50%, allowing us to detect vulnerabilities early in the development lifecycle. This prevented costly rework and delays later in the process. Additionally, the system's ability to generate audit-ready reports aligned with the ATO approval process, streamlining compliance and ensuring readiness for deployment in Azure Cloud One. This case study highlights how integrating agentic LLMs into the cybersecurity review process not only enhances security, but also significantly improves efficiency and compliance. These results underline the transformative potential of AI-driven automation in large-scale government projects. As we conclude, let's recap the key takeaways from today's presentation. First, agentic LLMs are transforming cybersecurity by automating traditionally labor-intensive tasks like code reviews. They don't just make up these processes faster, they make them smarter and more accurate. Second, this approach enables a proactive security posture. By continuously aligning with evolving standards, organizations can stay ahead of emerging threats. Third, the scalability and efficiency of these tools means that even the most complex and large-scale projects can be handled with ease. This not only saves time, but also optimizes resource utilization. Finally, the strategic impact cannot be overstated. By automating routine tasks, cybersecurity professionals can redirect their focus to addressing high-priority challenges and innovating in their field. Now is the time to embrace AI-driven solutions. Whether it's agentic LLMs, RAG tools, or frameworks like LangGraph, these technologies offer unparalleled opportunity to elevate your cybersecurity practices. I encourage you to begin exploring how these tools can be integrated into your DevSecOps pipelines. The future of cybersecurity is here, and adopting these solutions today will help you stay ahead of the curve tomorrow. Thank you for attending my presentation today, and please reach out to me if you have any questions. We are in the process of putting together a GitHub repository with examples and more detailed instructions on how you can implement these processes for your organization. Thank you very much. Goodbye.